Hey everybody, it's Mrs. Slauson. This is our week 9 video. It's going to be pretty short. Just a heads up, I am at home. I'm sitting on my couch. It's Sunday and I'm in pajamas and you are not going to be seeing me in this video. So this video should be pretty short. You do not have a handout for this. You're more than welcome to print this up. It will be available on Schoology. You can just watch the video. You can get a piece of paper and join me on a couple of them, but you will not be needing to turn in these notes to me. All right. This is just to get you ready for our little follow-up activity that you'll be completing on Schoology. All right. So we are going to be reviewing our average rate of change. Remember, that's just another word for slope. And to do this, you will need a calculator. So I've got my calculator next to me. So if you need to pause the video to go grab a calculator, go grab one. And we're going to get started. In week 9, when I see you in class this week, we will be completing our 6 showcase of learning. So this is in preparation for that. So the first thing, I just want to remind you of the formula for average rate of change. It's just another word for slope again. And that's if you're given an X and Y coordinate. Whoops. So you'll need 2 X and Y coordinates, and you will take your Y's and subtract them on top. And then in your denominator, you will subtract your X's, not add them. You can turn them into adding, especially if you have a lot of subtraction and negative numbers. And when you're done and you get your fraction, you will want to go one step further and divide your fraction so that the denominator is always 1, because a rate is out of 1. So just keep that in mind. And again, make sure however you subtract the Y's is how you subtract the X's, and to use your calculator. So let's just try a really basic one. You're given 2 X and Y values. So what you're going to do is take your Y's, the 10 and the 16, and put them in the numerator, and we'll subtract them. And you have a choice. You can do 10 minus 16, 16 minus 10. I'll just do 16 minus 10 because that's easier. And when I subtract, I get 6. So since I've decided to subtract 16, take away 10, then when I subtract my X's, I'll have to subtract them the same way. Not because it's easier, but I'll have to do 5, take away 3. And when I do that, I get 2. And then I'll want to go one step further. And if you don't know what 6 divided by 2 is, you turn on your calculator and you do 6 divided by 2 and you hit your enter button and you'll get 3. Technically, I don't need the 1. So in the answers, you could write 3 over 1, or you could just write 3. And either of these would be fine for the average rate of change. So what the quiz is, the showcase of learning is also going to cover is, can you explain it in context? So that's where we're going to spend the bulk of this practice. So if you notice in problem 2 and 3 and 4, and then 5 is coming up, we'll determine the average rate of change, and then we'll explain its meaning in context and be sure to use correct units. It does say round to the nearest thousandths. We're just going to go to the hundredths, which means 2 places behind the decimal. So if you look at problem 2, this is the height of a plant. On day 3, it's 15 centimeters, and on day 8, it grew really fast to 35 centimeters. So I want to know what the average rate of change is for this heights plant. So I will take the days and make that my X, the height, and make that my Y. And I'll create my fraction, and now I'm going to decide how I want to subtract the Y. So I would like to do 35 and subtract 15 because that's just easier to do, which will give me 20 in my numerator. And then when I subtract the X's, I'll have to subtract the same way. I'll have to do 8, take away 3. And when I do that, I get 5. This is easy to divide, but you can also use your calculator, and you get 4, and you put it over 1. So now becomes the challenge of, let's put it in context. So if you notice, everything in the Y is your height. Everything up here is your centimeters. So I'm going to put a quick little cm up here so I remember that. And then everything for my X's, that's the days. So everything down here represents days. And so now I'm going to explain how the plant is changing in height. And this isn't the only way you can do it, but for instance, I'll just say the plant is growing and I would say 4 centimeters every day. And that's it. Or I could say every day the plant is growing 4 centimeters. So whichever makes more sense for you. All right, next problem. So we're going to take a look at our distance driven. So again, our hours, our time is always X, and our miles will be our Y. And I'm going to make my fraction, and I'm going to start to subtract, and I'll do the Y's of 340 subtract 110. So if you don't know what that is, then, those are bigger numbers. It's been fall break, so you just turn on your calculator, you subtract them, and you get 230. And now when I subtract the X values, I'll do 6 and subtract 2, which gives me 4. And then I'll need to divide them. So remember, division only works one way. You have to do 230 divided by 4. This is a nice decimal, 57.5, and again, it's over 1. And now I'm going to put this in context. So everything in my numerator, these are all the Y values. And the Y values represent the miles. And then when I get to my X values, everything in the denominator represents hours. So I'm just going to put hours down there. And now I can see how I'm changing over time in my car, for instance, if I'm driving. So you are, let's say, driving 57.5 miles every I'm going to run out of room, hour. And that's it. Or I could say every 1 hour, I'm driving 57.5 miles. And this would then, for instance, be my average speed. All right, the next one, how has the population grown from 1900 to 1990? And if you look at what this is describing, the U.S. population by census. So what I need to do is I've got my X values, but what I'm going to have to do is figure out the Y values. So the X values, we can look at them as 1900, because that's down here, and 1990. And then I'll have to figure out the Y values by looking at my graph. So if I go to where X is 1900, so that's right here, and I go to the Y value, that's that 75. So this point right here is it. Now it's not just 75, it's 75, and it says over here in millions, but I'm just going to write 75. Now when I go to 1990, again, I want to look along my x-axis for 1990. That's right here. I'm going to go up. Whoops, you can see that happen. And then we go over, and that is 250. Let's erase that a little bit so you can see it better. So 250. And now that I have my coordinates, I'll put the y's on top and the x's on the bottom. So again, I just have to decide how I want to subtract. So I'm going to do 250. And remember, this is in millions. Take away 75. And then in the denominator, I'll subtract my time. So 1990 minus 1900. And again, if you need a calculator, you're more than welcome to grab one. So you'll do 250, take away 75, 1990, take away 1900. And when you're done, you get 175 over 90. So again, what I have to do is get my denominator to 1. So I'll, in my calculator, type in 175 divided by 90. And here I get a decimal. So it's going to be 249 point. And then I have a bunch of sixes repeating after the 1. So I'll just round it up to 17. Okay? All right, so now we're going to describe what this means in context. So again, everything in the numerator, whoops, I didn't mean to highlight that first part, just this part. Everything in the numerator, these are my y values. So this is the population. This is my population in millions, but I'm just going to write POP for population. Everything in my denominator now, that's my x value, and x is the years. That's what my x value or x axis says. So that's the years. And now I can say how the population is changing. So the population, whoops, is growing, and I know it's growing. One, I can see that from the graph, but I also know it's growing because my slope or my average rate of change is positive, not negative. And I'm just going to say 249.17 million people every year. And that's, again, that's an average rate of change, which that's pretty fast growing population if you ask me. All right, the very last one, problem 5. So below is a time chart charting an ultra runner's distance in miles after so many hours. So ultra runners are crazy people. They like to run really far, 50 miles, 100 miles. So anyway, so if you see time 0, no one started, they have no miles accumulated. Then after 9 hours, runner A and runner B are both at 120. Then you can see after 20 hours how many miles they've run in total. And in total, after 31 hours, you can see how many miles they've run. Okay, so when comparing the distances ran by the 2 runners in the first 9 hours, so let me do this, I'm going to erase this highlighting. So just in the first 9 hours, so here, that's all I'm focusing on. What do you notice? Well, what I notice is the runner A and B run the same distance. In 9 hours. All right, so now what we want to do is what is each runner's pace from 9 hours to 20 hours. So I'm going to do this erasing of the green. And I'm going to take a look from 0 hours to 9 hours. And I messed up. So 9 hours to 20 hours. And we will get our values here. So runner A, we're going to use, again, time is X, and their mileage, these are the different Y values. So for runner A at 9 miles, he's at 120 miles. But at 20 hours, he's at 168. And then for runner B, let's put him in a different color. Runner B will be 9 hours at 120, and at 20 hours, 213 miles. So what is each runner's pace? So we're going to answer this question first, and then we're going to answer who ran faster. Well, I can already see who ran faster. Runner B ran faster because runner A only got to 168 miles and runner B got to 213. So I already know who ran faster. That's obviously runner B ran the fastest. Let's go ahead and answer that first question though. So what is each runner's pace? So the pace is miles per hour. So miles is the Y, that'll go on top. Hours is the denominator. Those are the X's, they'll go in the denominator. So let's stick with the same color for our different people. So runner A, I'll just take 168, subtract 120, and then I'll take 20 and subtract 9. So 168, take away 20, that's 48. Again, if you need a calculator, grab a calculator, it's no big deal. I'll need it for the division. And 20, take away 9, that's 11. And then I'll want to divide 48 by 11. And when I'm done, I get 4.36, a bunch of 3636 repeating. So I'll just leave it at 0.36. Now with runner B, I'll put his Y's on top, make a whole new fraction. So I'll do 213, take away 120. Which means I'll have to do, as far as the denominator goes, also 20 take away 9. Well, I already did 20 take away 9, that's 11, but 213 take away 20 is 93. If you look, I mean, it's not quite double, but that's a lot faster. So 93 divided by 11 is 8.45, bunch of 4 5s repeating, so I'll just cut that off. And now I can see who is running faster. So let's finish up the one in pink. Runner B is running 8.45 miles per hour. And in green, we know that the other runner is running 4.36 miles per hour. And again, I know that it's miles per hour because everything in the Y values, okay, all of these Y's were the miles. And then as far as the denominator goes, which were all these X's, that's your time, that's your hours. So when we get it down to 1, this is hours, this is miles. I'll write it over here too. and then hours. And that's it. That's your quick little video. Now you're ready to jump into the practice. It's 10 questions. You may make 2 attempts at this. It will be the best score of the 2 will be entered as a score in PowerSchool. So if you get 5 out of 10, 5 out of 10 is entered. If you get 10 out of 10, 10 out of 10. This is not going to be an effort based. So make sure you have your calculator and take your time when you go through this. All right, that's it.